This question is related to the projectile motion. The photograph shows an area of a land where golfers can practice their golf shots. Distances are measured out along a land in front where the golfers stand to measure the distance traveled by the ball. Two levels are available. If the lower level is used, the ball lands at the same height from where it was hit. If a higher level is used, this enables the ball to hit further, like travel a greater distance, horizontal distance. The ball is given initial velocity of 33 meter per second and it is launched at an angle of 28 to the horizontal. When the ball hits from a lower level, like when the ball, as you can see, the golfers on the lower level, it land on the same, but when a golfer hits the ball from upper level, it cover a greater distance. So when hit from a lower level, the ball travel horizontal distance of 92 meters before it lands. Using the higher level increases the horizontal distance travel before it lands by 10 meters. Deduce whether on an upper level at a height of 4.5 meter would be sufficient to produce this increase, and you should ignore the air resistance. So we should ignore the air resistance. So launching speed is given. The launching speed is 33 meter per second and it is making angle, according to the question, it is making angle 28 degrees. So we assume that it is also hit with the same speed, like 33 meter per second and at an angle of 28. So both will have the same horizontal component. This will have a horizontal component 33 cosine. The horizontal component is 33 cosine 28 or cos 28, and the vertical component will be 33 sine. And same thing for this one. This will be 33 cos 28 and 33 sine 28, the horizontal and the vertical. So first we will find how much time it will take to reach the ground, because that using a time interval, we can identify what will be the extra distance, horizontal distance covered by ball at an upper level if it is hit from the upper level as compared to a lower level. So we'll use the formula first, the horizontal and the vertical component. The horizontal component will be 33 cos 28 and the vertical component will be 33 sin 28. Then to find the time, like how much time it will take, as we mentioned here, that when it is hit from a lower level, it cover about 92 meter. And when we hit from the upper level, it covered 10 meter extra. So what is the distance covered? The total range is there. Upper level, it will cover about 102 meters, where lower level, it cover about 92 meters. So we have the distance. We have the distance here and we have the horizontal component. So we'll find how much time it will take to reach the same level. And using this time, we will work out, because this is a time, the extra time it will take. So using this time, we'll work out the component of the velocity, what velocity it will hit the ground. So we substitute u cos 28, the horizontal component, where u is equals to 33. So 33 cos 28, this will give us the horizontal component, which will come out as 29.1 meter per second. Now, after knowing the horizontal component, we will find how much time it will take to cover this 102 meters. So we have the formula speed is equals to distance divided by time. So time, the total time it will take, that is distance divided by speed. So distance is how much? 102, and the speed at horizontal speed, that is 29.1. So the time, it will take about 3.5 seconds to reach the, this will take about 3.5 seconds to reach the ground. So we want to find now what should, from what height it must be launched so that it can cover 102 meters. So we'll use the equation of a motion S is equals to ut plus half at square. And now this u is a vertical component, and the vertical component is 33 sine 28. So this 33 sine 28 is u, which is equal to the vertical component, which is equals to 15.5. So this is 15.5 multiplied by time. It is taking 3.5 seconds, the total time, plus half acceleration is due to gravity minus 9.8, and the time is 3.5 square. When we solve this, it will come out as 5.87, but negative. What does it mean? Negative means it must be launched 5.87 meters above the ground so that it can reach this 102 meter, the horizontal distance. So according to the question, they mentioned deduce whether the upper level at a height of 4.5 meter would be sufficient to produce this increase. So it should not be 4.5, it should be from 5.8 meters above the ground. This is the second part of the question in which we are considering the air resistance as well. Your answer to part A did not consider the effect of air resistance. The trajectory of the motion of a golf ball with air resistance without air resistance. You can clearly see with air resistance, shorter like range, without air resistance, theoretically longer range. Explain the difference in the two paths. Why the two paths are different from each other. So one is with air resistance, another one is without air resistance. So when with air resistance is there, as it is going up, so two forces which are acting, because air resistance always try to oppose the motion. So one is the weight of an object which is acting downward, and the other one is air resistance, which is trying to oppose. Air resistance always try to oppose the motion. So as a result of these two downward forces, there will be a resultant force downward, and due to this resultant force downward, the object will, because resultant force and acceleration or deceleration are directly proportional. So what happened in the vertical part, as so when it is moving up, the weight and the vertical component of a air resistance will also have the component horizontal and vertical, because air resistance is also making an angle here, as you can see. So this is the air resistance. So air resistance is also making angle. The horizontal component will be there for air resistance and a vertical component for air resistance. And air resistance always try to oppose the motion. And weight is already acting downward. So weight is already acting downward, and there's a vertical component of air resistance is also acting downward. So as a result, what happened? The total downward force increases. If the total downward force increases, the deceleration will also increase, because when it is going up, it is moving against the gravity. So greater downward force, greater deceleration. And when it has a greater deceleration, greater change in speed, the maximum height reached by the projectile will also decrease. So when it is moving up, air resistance and is increasing, so the resultant force, and as a result, what happened? The deceleration increases, so its velocity will change quickly, or the maximum height will be lower. So greater downward force. Because the vertical component of air resistance and weight acting downward, so greater deceleration. As a result of a greater deceleration, so it will have a shorter maximum height. The maximum height which is reached by the projectile will reduce, or it will be shorter. What about the horizontal motion? Because originally we assume horizontal there is no air resistance to oppose the motion, but now as it is moving, there is a horizontal component of a air resistance. So as a horizontal component of air resistance, it reduces. So now there is a deceleration. The horizontal component of air resistance will produce deceleration. As a result, when it produces deceleration, it will have a small speed or lower velocity, horizontal speed, or reduce the horizontal speed. So it will have a short range. So range will also decrease and the maximum height will also decrease.